We hear the words positive or negative from a doctor and think we know what they mean. But what if it's more complicated than that? Today, we're going to pull back the curtain on medical tests and really get into two super important ideas that get mixed up all the time: sensitivity and specificity. Okay, so picture this. You go in for a heart test and the doctor calls, the result is positive. I mean, your heart just sinks, right? Your mind starts racing. But hold on, does a positive result actually mean 100% that you have heart disease? Well, not always. And to figure out why, we need to understand our first key concept. And that first big idea is something called specificity. The easiest way to think about it, it's the rule-in power of a test. It's what helps a doctor say, okay, this positive result looks legit. So to make this all make sense, let's use a real-world example we can all picture: the exercise ECG. You know the one. You're on a treadmill hooked up to a bunch of wires while they monitor your heart. It's a super common way to check for things like coronary artery disease. All right, so here's the tricky part about specificity, the thing that kind of flips your thinking on its head. It's not actually about finding the people who are sick. Nope. It's all about how good a test is at finding the people who are healthy and telling them correctly, hey, you're all clear. It's about finding the true negatives. So if a test has high specificity, what's it really good at? Well, it's brilliant at avoiding false alarms. Its whole job is to cut down on those dreaded false positives. When a test tells a perfectly healthy person that they might be sick. Talk about stressful. Okay, so back to our exercise ECG test. Turns out it has a specificity of around 77%. But what does a number like 77% actually mean when you're the one getting the test? Well, let's break it down. Imagine we take 100 people that we know for a fact are totally healthy. We give them all this test. That 77% specificity means it's going to correctly identify 77 of them as healthy. Great. But, and this is the really important part, it's going to get it wrong for the other 23. It's going to flag them with a false positive, telling them they might have a problem when they don't. And that brings us to a really simple but powerful rule of thumb. If you get a positive result from a test that's known to be highly specific, that's a pretty strong signal. It helps your doctor to confidently rule in the disease. All right, so that's what happens with a positive result. But what about the flip side? Let's say your ECG comes back negative. Phew, sigh of relief, right? But does that mean you are 100% in the clear? Well, to answer that, we need to look at our second tool. And that second tool is called sensitivity. So if specificity was all about ruling in a disease, you can probably guess sensitivity is all about ruling it out. This is the one that gives you that real peace of mind when you get a negative result. So what does sensitivity measure? It's all about how good a test is at finding every single person who actually has the disease. Think of it like casting a really wide net. The goal is to not let anyone slip through. And the reason you want that wide net is to avoid the one thing we all fear: a false negative. That's the absolute worst case scenario, right? The test says you're fine, but it's wrong, and the disease is just hiding there, undetected. So what about our trusty exercise ECG? How sensitive is it? Well, the data says it's about 68% sensitive. Okay, let's do our 100-person thought experiment again. But this time, all 100 people genuinely have heart disease. A test with 68% sensitivity will correctly catch the disease in 68 of them. But it's going to completely miss it in the other 32 people. 32. That's almost a third of them getting a false negative. And that, right there, is why a negative result is not always a get-out-of-jail-free card. So this gives us our second big rule of thumb. If you get a negative result from a test that's known to be highly sensitive, that's when you can really breathe a sigh of relief. If a test is designed to catch absolutely everyone, and it says you're clear, that's what lets a doctor confidently rule out a disease. Okay, so we've got these two big ideas, right? Specificity for ruling in and sensitivity for ruling out. They almost sound like they're fighting each other, but really, they're like two sides of the same coin. Both of them together are what tell you how accurate a test truly is. So let's just put them side by side for a second. On one hand, you've got sensitivity. Its goal? Find everyone with the disease. The error it's trying to avoid? False negatives. So we call it the rule-out test. Then you've got specificity. Its goal? correctly identify everyone without the disease. The error it avoids, false positives. So we call it the rule-in test. See how they work together? They're a team, and each one covers the other's weakness. All right, I know this has been a little technical with percentages and weird names, but what does all of this actually mean for you? When you're the one sitting in the doctor's office? How does knowing this stuff actually help? Here's the bottom line, the stuff you really need to lock in. First, a positive result does not automatically mean you are sick. It could be a false positive. And second, a negative result isn't a 100% guarantee that you're healthy. It could be a false negative. And this right here is exactly why doctors almost never rely on a single test. It's why they do follow-ups and other procedures to get the full picture. So I want to leave you with this one last thought. The next time you see a headline or hear someone say a test is 99% accurate, you'll know better. You'll know that simple number is hiding a much more interesting story. And now you'll be able to ask the really smart question. Okay, but is that 99% sensitive or 99% specific? Because now you know the answer to that question changes everything.